Hi everyone, thanks for joining this webinar. We've actually only booked an hour of your time, so I'm just going to jump right in. We are recording this and we'll provide a link to the recording to everyone, so no worries if you're having connectivity issues or you have to drop out early. We'll be sending out the recording for everyone. In today's webinar, we're going to go over the basic workflow in CHEMCAD. And in the beginning of my career, I jumped into process engineering without any formal training in process simulation. Even in university, I did use a process simulator for my senior design project, but we didn't spend a lot of time talking about best practices or really learning, the guidelines for how to best get started and use a process simulator. So if that sounds familiar to you, if you're looking for some guidance on the fundamentals, then this is the right webinar for you. Or if you have experience or training and you just want to brush up on what the latest version of CHEMCAD looks like, then, welcome to you too. But with that, I'm going to go ahead and get started. Just a little bit about my background. My name is Noelle Garza. I've been with ChemStations now for going on 3 years. I have a degree in chemical engineering and have been working in chemical engineering simulation to some degree for about 14 years now. I started out in traditional process engineering, but then I realized I loved working with simulation tools specifically, so I moved my focus into, chemical engineering simulation, essentially. And with that, there are a lot of people attending this webinar from different backgrounds and different experience levels. So I did want to spend a little bit of time introducing the user interface for ChemCAD, or the GUI, as some people call it. But I want to spend a bulk of this hour actually building the model, building the flow sheet in ChemCAD, and running the simulation and viewing results. So just a quick intro to the user interface, and at the end, I'm going to quickly show you how to add complexity once you start building the process simulation and trying things out. You can add complexity and get as complex as you want to get there, but I don't have enough time in this webinar to do that. In fact, a basic ChemCAD process simulation course is going to be a 3-day long course. So I'm trying to squeeze as much as the fundamentals into 1 hour as possible. And that's based on the fact that, again, when I first started out my career as a young engineer, I was eager to get started. Didn't quite know how to start, didn't get any formal training, and it was really unclear how to get started sometimes. There's so many unknowns in the early design stages of a project or in the early part of solving a problem. And what I hadn't quite realized yet is that, unlike university where they give you a problem set and they kind of help you make assumptions and get started just to learn about chemical engineering and solve the problem. But when in the real world, there's so many things that are unclear and unknown, and a lot of it is digging up information, and a lot of the big challenge is, how do you start to make assumptions? How do I even get started? And even if your process simulation is up and running, but you need to expand or troubleshoot something, and there are natural fluctuations in process conditions for your existing process. So there's still a lot to be explored there, even if you already have an existing process up and running. And that's where ChemCAD really shines. You have so many unknowns, and you need to solve a complex set of nonlinear equations, and sometimes you just need to get some quick answers. And even if you don't get the exact answer right away, you don't need the exact answer right away, you get to learn something about your process and move on. And the beauty of ChemCAD is you're testing in a virtual environment, so nothing's going to explode in your face if you try things out, and really push the simulator to the brink to kind of find out, explore your process, explore what's going on, and what you can do to troubleshoot or to be innovative in your design. And I say all this just because I did work in technical support for a few years, and I've seen people fall into the trap of trying to match exact names to match a specific piece of equipment, or looking to exactly match the components in your component list. Like, I'll use the example of air is comprised mostly of nitrogen and oxygen, but actually there's a lot more components that we can find in air: hydrogen, helium, things like that. But for most processes, we can simulate and say, like, just assume air is nitrogen and oxygen, right? We don't need to create this high fidelity model, which ChemCAD can also do. But I wish I had known in the early part of my career that we don't have to simulate the process exactly as it is in the real world to get a viable answer. It's a lot of exploring and trying things out and making assumptions and moving forward from that, learning from what the process simulator can tell you. And I like to compare ChemCAD to like a hammer, for example, and sometimes I'm using a hammer to carefully nail something into the wall, and sometimes I'm not careful with a hammer at all, and I want to bash something, break it apart, make a hole in the wall when you're remodeling, whatever. So ChemCAD is like that. It's just a tool to fit your needs in the moment. And so there are loads of features and tools in ChemCAD that you can use to get great precision in your answers, or to just get a broad look at the process, like as a starting point. So that's what I'm going to focus on today, is that kind of where do I get started? How do I explore a process in ChemCAD, starting from like a blank flow sheet, right? I'm going to go ahead and start the simulation for a natural gas plant, for example. And I'm going to have like a warm natural gas stream, and I want to liquefy it. And eventually I want to integrate my cooling streams, my refrigerant streams into the process of cooling, and really kind of add a lot of complexity to that process. But again, we're just going to start small and build the complexity into that. Here's an overview of of the recommended workflow in ChemCAD and how to get started. You need to choose components. You don't have to follow this exact order, but I like to start with choosing the components and the thermodynamic models first. Thermodynamic models are going to depend on the components that you've selected. And also, you may find as you're choosing components and building models that you may need to gather additional data, maybe some experimental data to make sure you're accurately predicting the phase behavior. Maybe you need some reaction equilibria for reactions in your process. So I like to consider the components and thermodynamic models in the early stages of the process modeling, and then you can build your flow sheet and little by little add complexity from there. But yeah, ChemCAD is flexible. You don't have to follow this exact workflow. You can start building your flow sheet first and choose components later. You can add components later through your process if you forget something. But this is really kind of the best practice workflow that I would recommend. And so I'll just actually go ahead and get started demonstrating ChemCAD for you now. So if you have not seen ChemCAD before, this is what the interface looks like. At the very top, you'll see the version number. This is ChemCAD NXT 1.1.2. And this is the on-premises version. There is also a web application version where you can access ChemCAD through your internet browser, through the cloud basically. But this is the on-premises version, which is installed directly on my machine. Just below this is going to be the ribbon menu. This is where we're going to utilize a lot of our most common features like selecting components and thermodynamic settings. There are other tabs here with more information, but like I said, I'm not going to go into detail into everything that's in ChemCAD. Just in the interest of time, I want to go ahead and get started building a simulation. So I just want to focus on the home tab for now. This is where I will start by selecting my components. I also want to point out engineering units here. This is, I have it as the English units as my default profile. I can go in and make changes as I want, and I can save as a new profile. For example, if I have like project specific engineering units that I like to use to that project, and if I'm on multiple projects, it's nice to be able to kind of switch back and forth quickly between preferred unit sets. But for now, I'm just going to stick with the default English unit profile. And the other thing I want to talk to you about before we get started is we're going to be working in the steady state mode. There's also dynamic functionality in ChemCAD that is going to add more complexity and more specifications. So that entirely can be its own webinar, but for the purposes of this kind of basic webinar, I'm going to stick with steady state. Steady state is good for a lot of engineering purposes to make your, early judgments and calls on how to solve your processes. And beyond run is the charts and reports, which I use quite a bit in process simulation. I'll show you more examples of charts and reports as we move along, but this is a very common part of the engineering workflow that I use here in the Home tab. And if you look off to the side, you can actually minimize this ribbon menu to maximize your workspace. If you're building large processes, I like to maximize my workspace as well. But if you do that, I'm going to just pop over here and put the ribbon back. But if you do that, I recommend you add more functionality to your ribbon menu. You can see here I've added a few things, like I can say if I want to add select components up there, I just right click on select components and I can say add to my quick access toolbar, and then it pops up there so that when I hide my ribbon menu, I can just quickly access some of these features. So that's a basic introduction to the ribbon menu. The Explorer pane is here to the left. You can, again, close all of these panes and just go to View, and you'll find them there. But just to quickly mention the Explorer pane, you first, by default, you can browse through recent files, but as you start to build your simulation, there's a simulation tab down here, and this will start to populate with the unit operations and streams and things that you start to add into your simulation. Another thing we definitely don't want to neglect in this webinar is the messages pane. And as I like to maximize my workspace in the middle, a lot of times I'll close the messages pane. But let me go ahead and click on View and add the messages pane back in. When you're running and troubleshooting a process, this is really important to keep open so that you can check errors and warnings that pop up as you're running through your simulation. This one has 2 warnings, which is just because I haven't specified anything yet in my flow sheet. But notifications as you're running, notifications will pop up. And the notes tab is for you to go in and put notes in as you go along in your simulation. And this is where I like to put a lot of the assumptions that I'm making through my process. And it's so important because sometimes you converge a simulation and you forget how you got to that point or why you specified, certain things in your streams and unit operations. And so you can jot those down in your notes tab for you to review later, or for a colleague when you pass this on. They'll know kind of what your assumptions are and why you did what you did, what's going on in your process. So don't neglect the notes tab. And the other thing is the palette here on the far right side of your screen. This is where we're going to be able to drag and drop the unit operations onto our workspace. One thing of note is you can change the color of your unit operations. I like to use that if I have a complex sheet, flow sheet, for example, and I want to find all my compressors, easy to visualize where all my compressors are, bright red, things like that. So, but for this purpose, I'm going to just keep moving on with grayscale. And that pretty much completes a tour of the interface, the most commonly used features anyway. As I said before, we will have more webinars on more specific features and topics, and so stay tuned to find out what the rest of the features in CHEMCAD can offer. But for this purpose, I'm building a basic workflow, so I am going to start with selecting components. In this case, I'm going to have a natural gas stream, so I know I'm going to need methane, ethane, propane. I'll add nitrogen, and maybe I'll have water. I'm just going to add water. You can double click on the components as you find your filter for your available components, and then click on this arrow here to add it to your selected components list. So this comes from a massive database that's in CHEMCAD, and there are over 2,000 components with component data available. So for many processes, there are a lot of components available, but if it happens that your component is not in CHEMCAD, then you can add a component to the component database, add a user component. So, but for now, we're going to use these kind of known components here, and to add these to my process, I'll just click OK. And CHEMCAD will actually help you select a thermodynamic model based on the components you've selected. So you can choose to neglect some components. For example, I've got water in there. I'm not going to have water in the early part of my process. I want to focus on the natural gas. Water is a polar component, and I don't want that to be taken into consideration when we're choosing a thermodynamic model for my modeling the phase behavior of my natural gas. So I do know I want to get to very cold temperatures, so I'm going to put -250 as my temperature min and see what CHEMCAD comes up with. So CHEMCAD has selected Peng-Robinson. The PR stands for Peng-Robinson. That's what it's recommending based on the selections and the components that I have given it. But you can go here to the global K-value model, drop down, and see that there are many other models that you can choose from. Peng-Robinson is a cubic equation to say it's actually developed specifically for oil and gas purposes, so it does really well for something like a natural gas. But I mean, not everyone in this meeting is going to be interested in natural gas, and I just wanted to demonstrate that we have, activity coefficient models, uh, different equations of state, different empirical models, and some are more valuable to processes that you might be interested in. And actually, I could spend probably multiple days, a multiple day course talking about thermodynamic settings and everything available, and how to get accurate thermodynamics for different processes. But in the interest of time, I'm going to just move forward with Pang-Robinson, and for the enthalpy model as well, I'm just going to use the default recommendation. From my background, I think that this will do a really fine job doing what I need it to do. So I'm going to move forward and click OK. So now I've selected my components and thermodynamic settings, but I want to start building my process. What do I need to do? I know I'm going to cool my warm gas stream. So in the palette, the first at the top is going to be all your unit operations, but you can also filter down here. These are all included in the all unit ops, but this is just an easy way to filter. So I know I'm going to cool a stream, so I'll just grab a feed stream and a heat exchanger. Something to note about the icon here, if I right click this heat exchanger, there are many other icons that I can choose to represent my heat exchanger in my flow sheet, but the calculation is actually going to take place in the specifications window. So I can just grab whatever icon I like and drop it on the screen. You can see here I could have, had something like evaporators or plate and frame or air cooler. There's lots of other icons if you prefer to use that in your process. But this is just the general heat exchanger icon. And if I double click on that, my specifications that I enter are going to be what represents the calculation, not so much the image that I've selected to appear on my flow sheet. So you always need a feed and a product stream to run a calculation. So, sorry, just to clarify, the feed stream, so something going into the inlet of a unit operation, is going to have this kind of reddish, looks kind of a pinkish dot here. So if I hover over it, my cursor turns into a pointy finger, and I just click and hold, and I get this red box, and it's showing that I can connect to a blue dot, which is going to be the inlet to the heat exchanger. And then for the product stream, I'm going to start at the red dot. This is the outlet of the heat exchanger, and I'm going to click and hold to get to the product stream. And when I see the anchor there, I can just release my mouse, and I've connected now to the product stream. And the next thing I want to do is to specify what's coming into my feed stream. I can name this stream if I want. It's not required. I'm going to specify, say, 110 degrees and 735 psi. I like to look at my component list in mole fractions or mole percent. So I'm going to go ahead and tell it 75 mole percent, 20 mole percent, say 2 and 3 mole percent, and I'll just neglect water for now. And then I'm going to just have a large flow rate for the purposes of this webinar. It's not really necessary. I can flash the stream, or I can just click OK and it'll go ahead and flash the stream for me. Get your enthalpy and property information of the stream. If you notice how I got that table up here is I hovered over the stream. This is called your quick view. I can choose to ignore the quick view sometimes when I have like really complex processes, and as I'm navigating around it can get a little bit annoying to have this quick view pop up. So I can ignore it using this toggle on off feature here. And so now when I hover, I ignore it. If I prefer, I can add a stream table down here if I prefer that to like the quick view. Let's see. I'm going to go to drawing, stream box, and I want to actually add a stream box for say 1 and 2. So in this case I'll just say all streams. And this is my default property sets included with CHEMCAD. I can add a new property set if I want to look at something specific, or I can go in and edit, what showed up for my quick view. For example, I can tell it instead of mass streams, again, I like to see it in mole percent, for example. Or I can say stream properties and choose mole fractions there. And so for my stream table, maybe I just want to look at stream properties. And then actually I like to see temperature and pressure as well. Okay, so good. That's going to be included in my stream property table. So now I click OK, and the stream property table appears on my flow sheet. I don't know if you can see it very well. It's very small for me, even on my own screen. So what I can do is right click, go down to the bottom, style and text, and I want to increase the size to like 60, for example. And okay, so what I just did there was I used my scroll wheel to scroll out, and that's just because I want to expand this table a bit to make it easier to read. There we go. Something that I didn't mention in my tour of the interface is down here at the bottom right corner. That's where you can access the zoom features, and you can either use your scroll wheel on your mouse if you have one, or if not, you can use this kind of zoom button to zoom in. You can use this, I use this a lot, the zoom to fit feature, where you click that and it zooms and centers everything in your flow sheet. So if you have this big massive flow sheet, it's going to zoom out quite a bit. And the little auto pan hand icon here, you click and hold and it kind of grabs the flow sheet and it makes it easier to move around. I'm still using the scroll wheel on my mouse to zoom in, but you can also use this zoom in down at the bottom. But I need my mouse pointer back. I want to get rid of the little auto pan grabby hand. So I'll single click on that, and now I have my standard mouse selection tool here. So anyway, that's just a little side note on using the zoom functionality in CHEMCAD. Let's see, what do I need to do next? I need to specify my heat exchanger. So I mean, I'm sure you can guess what the next steps are, but let's say this is like a really new starting point for you and you don't know how to approach solving the problem, what I do know about my process is simply that I'm going to cool the stream to become a liquid. I don't know what temperature natural gas cools at. So how do I know how to specify this heat exchanger? I can guess and check. In my temperature of stream 2, that's going to be the product stream here. But is that really the best way to make assumptions and get started and make guesses? Just guess and check, that can take a lot of time. So this is what I was mentioning. Okay, I'm going to go back to the home tab. I'm just letting you know what I'm doing as I'm clicking along. So this is what I was talking about when I mentioned, understanding thermodynamics and utilizing the charts in CHEMCAD to visualize your process and visualize your models early on. So if I go to the charts feature here, the drop down, this is going to display the chart options available in CHEMCAD. And the charts at the top here are useful for a lot of times in separation processes like distillation. You want to use like a TPXY plot to visualize the vapor liquid equilibrium in your process. The thing I want to do to look at my natural gas stream though is the phase envelope. So I'm going to click on phase envelope and I'm going to say, show me the phase envelope for my stream 1. And you can choose some estimations, but I mean, I'm okay with what CHEMCAD has for the default. So look at this beautiful phase envelope for my natural gas stream. This is what CHEMCAD is predicting with the Peng-Robinson equation of state. My natural gas stream is about 735 psi, and I think it was 110. So I'm way off the chart in the higher temperature range of the gas phase. And as I move down cooler in temperature, I move closer to the red line, which is the dew point of the gas. So that's once I get to this red line where these red dots are, that's where my first drop of liquid is going to appear in my gas stream. And the blue line here represents the bubble point line. So if I have a liquid phase, then as I cross the bubble point line, I get my first bubble of gas appearing in my fluid. And then we have the critical point designated up here with the green line. So once you cross your bubble point or dew point, now you have liquid and gas phases. So that's what's going to be in the center of your phase envelope. And that's just a little refresher if you don't look at phase envelopes very much. That's kind of what I was looking at. So for my process, I want to cool down to the liquid phase, and I can read my chart and kind of guess like where am I at, like negative 20 at 735. So I mean it'll be something around there. So I can go back to my process and know that around negative 20 I'll probably want to cool my gas stream to around negative 20. So that's one way to utilize the charts and reports in CHEMCAD to visualize a process. Where are my boundaries? Where can I expect to see vapor phase and liquid phase and things like that? Very useful when I'm trying to feel out a process. So let's say I'm going to specify temperature of the outlet of my heat exchanger is going to be around negative 20. I say OK. And then I want to run all. So I've specified a feed stream. I've specified, you can see here, let me just double click back on this and point this out. So in green, CHEMCAD will tell you, like, at a minimum, you need to specify this much And so it says enter one of the following. And that enters into the discussion of degrees of freedom. You can over specify or under specify a process because, as I said, we have this kind of complex set of equations and lots of unknowns, and we have to help CHEMCAD make some assumptions to arrive to an answer, right? So CHEMCAD does its best to let you know how to specify the right amount of degrees of freedom. So in this case, enter only one of the following. If we enter too many data points, then you're over specifying the process, and ChemCAD's gonna not be able to likely not be able to reach a conclusion because you've given it too many boundaries. It doesn't have enough room to calculate, you know, based on the equations, what the answers could be. So don't over specify a process, don't under specify a process. It will an error or warning will appear. So let's say I forgot to, I'm going to click OK to get out of this. Yep, so it's spitting out an error saying, wait, you have to specify at least one thing for your heat exchanger so we can continue the calculation. So I do want to go back into my heat exchanger menu, and again, I was looking at my phase envelope, so let's go back to -20 and use that as my guesstimate for this process, let's say. So I click OK, and now I can say run all, and you can see my stream table here has updated with my new run. It does not update the stream table until you click run. If I want to edit my process streams, so in this case, this stream table is the process streams for this heat exchanger. I can right click on the heat exchanger and say edit unit op streams, and that's going to bring my view and edit capabilities for the heat exchanger stream. So maybe instead of 110, I want to change the temperature or pressure as I'm going along. But for this process, I just wanted to point out these commonly used features that maybe were not obvious, but that I use a lot. So okay, so we've specified -20, and I want to run all and see whether or not I'm achieving a little bit of liquid in my gas phase. But so far, it looks like vapor mole fraction of 1. I'm not sure exactly where I am in that phase envelope, so what I can do is go back to my phase envelope, and you'll see here at the bottom of the workspace, these tabs are where your charts and reports will appear. And okay, so I want to go back to my phase envelope, and if I see down here at the bottom of my workspace this untitled flow sheet, that's because I haven't saved my flow sheet. When I save it, it's going to have a name. But as I'm populating charts and reports, I can go down to the bottom and find my phase envelope, and I want to add that -20 guess and check type thing that I started with, and I can add that to my phase envelope by going to, under the charting tools, user series, new, and so I'm adding a new series to my phase envelope. I'm just going to call it data, and the data point was -20 at my 735 pressure. So if I click OK, I'm just adding a new user series. Now I want to add it to the chart, so I go back to user series and say that data point, add it to chart. And so now you'll see this purple data point appear, and you'll see like I'm pretty close to the dew point, but I didn't get it exactly right. And so this adding a user series is useful uh, especially if you have experimental data and you want to see the difference between your model, what CHEMCAD is predicting, and what you have experimentally determined to see like how close you are to the expected behavior of your process. So in this case, I'm close. I could try and do guess and check and take a long time doing that, but a little trick here, if I go back to my flow sheet and I want to go back to my heat exchanger specification, so double click on my heat exchanger. Something that you can do is if you specify a vapor fraction, so stream 2 is my product stream. If I specify a vapor fraction of 1, that's actually going to tell CHEMCAD to calculate my the dew point of my gas. So right at 1, it's going to calculate the dew point of my gas for me. So I'm specifying a vapor fraction for my product stream right at the dew point, and CHEMCAD will calculate it for me. So I click OK, run, and now we can see my stream tables populated. A temperature of negative 24.9 as my dew point for this natural gas stream. So I can go back to my phase behavior plot and go back to my user series. I called it data, and I can edit that. So it was negative 24.9. and it was at 735. So I say OK, and I want to add it to my chart. And now I can see I've actually, fallen on my dew point. And I mean, this is very basic example, but I wanted to use this to demonstrate to you. I wish in the early part of my career I had used charts and reports and thermodynamic simulation a lot more in the early stages of a process to help me understand. So, for example, I was doing a lot of pump sizing and, just looking at kind of these broader general processes, and my senior engineers would come and tell me just kind of what to do, but I didn't understand the process enough. I didn't have enough internal knowledge about what's going on and what expectations I would have from the process. And so say if you're doing a pump calculation and you don't know where you lie in the phase envelope, you want to make sure that you're not going to cavitate your pump. So it would be interesting to look and say, like, am I going to be concerned here about getting too close to the bubble point, for example? Or if I have a suction to a compressor, I want to be sure I'm not close to the dew point of my gas. So, excuse me. So it's just things like this to consider and utilize these thermodynamic modeling and visualization tools to help you understand your process better, especially if you're in the early stages or you're just not that familiar with your process or your streams. This is a great way to kind of visualize that and keep moving, making assumptions and moving along in your process. And I didn't look at the report. This is basically the report that prints out when you're choosing to set up a phase envelope. Right now it's in the internal viewer of CHEMCAD. If I want, I'm going to go back to my process flow sheet. If I want to view it in Excel, CHEMCAD can print all your data out into Excel for you, and then you can, work from Excel and do fancy things there and make fancy plots there if something's not available in CHEMCAD. So I like to make my default report viewer Excel, and then the next time I run a chart, for example, let's say I want to hit phase envelope again. Maybe this time I'll do stream 2 and say, okay, this is my product stream from my heat exchanger. And there's what my product stream looks like, and it's actually going to print out my data points in Excel now because I've selected that as my default report viewer. So I'm just going to close this, and I don't want to save anything. So that's a little bit of information about utilizing charts and reports. Okay, so we've figured out, like, at a minimum, we want to get down to -25 to start to get our process cool to a liquid stream. We could use guess and check. That takes a long time. So there are tools, charts, ways that you can run these calculations in CHEMCAD to get to your answer faster than like guess and check. But I will point out that there are probably 5 different ways to get to the answers you're looking for, to get to, arrive to a solution. So don't get stuck. Don't focus on, how to get there. Don't be afraid to work and play with CHEMCAD a little bit. And one thing I will point out now that I'm on this is the help menu here at the top. If you click on that, it pulls up a lot of help and references, including a user guide that can help you get started. And if you are not that comfortable deciding, if the thermodynamic model that CHEMCAD helped you select, is that, the right CHEMCAD, is that the right thermodynamic model for me? I don't know. I can look at, so like I have my Peng-Robinson equations today. I can look at the summary of equations and, kind of the strengths and weaknesses of my different k-value models here, and just do a lot of like exploring and what's available in CHEMCAD, and there will be best practices and things in the user guide and in the help menu that can help you make better decisions, make better engineering decisions. So take advantage of the help menu. Don't forget it's there. And I am running close to my time. It's again, the basic CHEMCAD course is like a 3-day long course, so it's very difficult to kind of go beyond this really basic level of like how to build a flow sheet and all the features available in CHEMCAD and what the workflow looks like. But let me just try and add a little bit more complexity. I can add, for example, the utility stream. So right now I just have my heat exchanger with a feed stream and the product stream of what's cooling now, but something's in there cooling it. So I want to add my refrigerant stream. I can just add a feed arrow and a product arrow, and again click on the little red dot and connect to the utility stream for this heat exchanger. Or it could, it doesn't necessarily have to be a utility stream. Maybe it's a cross exchanger and you have a recycle loop somewhere in your process. But in any case, so now I've connected the refrigerant stream into my heat exchanger, and I double click on the specifications, and you can see that there is some changes here because now I'm actually doing a heat material balance for both my feed stream, my natural gas stream, as well as the cooling stream, which I'm going to specify as cold propane. I haven't specified my feed stream yet, so let me cancel here. I'm going to double click on my new cooling stream. I'm going to call it propane. You don't have to name your streams, but I like to. Temperature is going to be like really a cold stream. Let's say it's 150. And just have a really large number for my propane. It's going to be pure propane in this case. Okay, so I say okay. And now I've added kind of another layer of complexity because now we have to tell CHEMCAD to do a heat material balance for what's coming in and going out. I don't really know what the flow rate of this stream is, so I can't actually go in and tell CHEMCAD to calculate the flow rate. And so stream 3, is going to be my cooling stream, and I want to tell ChemCAD to solve that for me. But as I was telling you before, we're going to have, you know, uh, we have a specific, we, as I was saying before, there's a certain number of degrees of freedom, and we don't want to overspecify or underspecify something. So ChemCAD guides us and helps us know how much specifications we need to achieve the calculation. So it says to enter 2 specifications and then the flow rate. So I kind of just threw in a guess flow rate in my propane stream, but they can recalculate the flow rate for me. So I might, say that the temperature of stream 4, let me just say it's going to be 60 degrees Fahrenheit. Okay. And now I can run all and check down here my messages. My run did actually finish and ChemCAD converged. So now let me hover. Oh, I turned off my quick view. So let me go back and toggle on my quick view. So now I'm going to hover over my stream because it's not in my stream table. I didn't tell ChemCAD I wanted to see it yet. I just added this new stream. So yeah, now I can check what my new flow rate is. It's quite a large flow rate for propane that I need to cool this stream down. Again, I can right click on my unit operation and edit unit operation streams, and so now all the streams coming in and out of that cooler I can view and edit through this way. Okay, so that's adding layers of complexity. So now I've solved my cooling flow rate. Another cool feature in ChemCAD that I did want to demonstrate for you, one more thing. I know I'm running out of time. If I go in this stream, I right click, I can drop in a unit operation pretty easily without having to break streams and delete streams and get all confusing like that. So insert unit operation, I want to insert like say a knockout drum for my liquids as I'm condensing my natural gas. So separators, I'm going to just use a flash stream, and I just click and drag over my stream that I had right clicked this and told it I was going to insert a unit operation into the stream. So when I click and drag it over that, then ChemCAD will automatically connect it. And so with this flash drum, at a minimum, I need a gas stream at the top, and I didn't have a liquid stream before, so it didn't automatically add one for me. So I need to add a product stream, a liquid stream at the bottom. So again, I need to click on the red to get the outlet of the separator and connect it to the product stream. And if I had, say, a water, an aqueous phase stream and a hydrocarbon phase stream, so I would have, 2 separate liquid phases coming out, I could add another liquid product stream, but I don't have any water in my process. So for this purpose, it's okay to just have a vapor and liquid phase stream coming out of this flash drum here. So, just like that, little by little, that's how you build your process simulation, adding in complexity and solving as you go along, making assumptions and solving as you go along. So you can see how I had made a bad guess. I was just kind of showing you like, if I guess and check, it could be a long process, but I arrived to a conclusion, and then I moved on and added complexity after I was able to solve little by little, starting from what I didn't know and figuring things out as I went along. And so that's kind of the recommended best practice for ChemCAD simulation. I did promise that I was going to show you a more complex natural gas stream. So if I go down to my recent file tabs in my Explorer pane, and I go to this LNG model, I don't care to save this process simulation. This is an LNG model where and I'm going to go down here to zoom to fit, get a little bit of a closer view. This is a model where we've started with our natural gas stream, and we have, the heat exchanger, and we're cooling it along, and we're adding a refrigerant. In this case, I have my propane stream, my pure propane stream, and I've also got like a mixed refrigerant stream that I'm using to cool. And so you can integrate and have recycle loops and refrigerant loops in the process, and just really get as complicated as you need it to get. You can see here, actually, there is, let me go back to my errors and warnings. You can see here there is a warning, even though I do show that my process has converged. So when I have this huge process simulation here, one easy way to zoom in to find my heat exchanger that my warning is about, it can be kind of hard to see. It is highlighted in yellow, but let's say I'm trying to find it. There's two things that I like to do to help me find things in a large complicated flow sheet. One thing is I can select all streams, or I can select specific stream groups, or specific unit operations. But if I select all streams, I can go into drawing and view, change the font to be much larger font so that it's easier to see. And I also like to use this feature when I'm printing out, because it's hard to read like the names of the streams or the numbers of the streams or unit operations. So just something to keep in mind that makes it easier. So that's one way to make it easier to visualize things on a process flow sheet. The other thing I like to do is use this home find, and then I can find the stream or the unit operation that I'm getting my warning about. So in this case, I'm getting unit operation 48. So I say OK, and it's very zoomed in, so I can use my scroll wheel to zoom out a little bit. But this is the heat exchanger that's giving me some problems. So I can right click on my heat exchanger, and there is plot heat curve. So I can click on that and say OK. And so now CHEMCAD is printing out the heat curve. And again, I've told CHEMCAD to make my default report viewer as Excel, but I'm not going to be looking at the tables for this purpose. Anyway, so looking at my heat curve, this is called a pinch zone of the heat exchanger, and that means that given your specifications, we can't physically heat or cool anymore because the temperatures are either too close together or have crossed, basically, because you have a hot stream and a cold stream, and at some point, if the hot stream isn't hot enough or if the cold stream isn't cold enough, it can't physically reach the specification that you might have told it to reach. So just something to consider looking at your pinch zone for your heat exchanger. And anyway, that basically sums up complexity. This is actually a pre-built example file. There are a lot of pre-built example files in CHEMCAD that can help you get started and help you explore. If you installed CHEMCAD, you can go to Open, and usually in your documents, it's by default when you load CHEMCAD, it's going to be loaded into Documents, My Simulations, and Examples, and this is NXT 1.1.2 version. I had older versions because I had other installed versions of CHEMCAD, but for this purpose, so I think this is under gas processing. So you can find a lot of examples, pre-built examples here for you to explore and help you get started in CHEMCAD. Maybe you'll find an example process that is similar to what you're going to be working in. So anyway, that is the that's pretty much in a nutshell how to get started in ChemCAD. Another thing that I did want to just quickly show you was under the analysis tab, if you want to get even more information about your process, I do like to recommend adding a sensitivity study. And I know this isn't as popular. A lot of times people use this to like optimize their process or just kind of see how sensitive something is, so they can, test out their process a little bit more. And it's something that I didn't use that much of early on, but I like to use it when I don't know a lot about my process and say I want to test, given in my heat exchanger, this range of heats that I want to play with from A to B. Let me just go ahead and click a new analysis. I'm going to call it test. And what this pulls up is you can tell ChemCAD one or more. I mean, it does multi-variable study. So you can have like an independent variable, say with your heat exchanger. You can tell it to vary, a whole host of things. There's so many things that you can vary, and I just wanted to focus on this, because again, I'm talking about in the early stage of a process or in some area where you don't have a lot of experience and you don't have a lot of knowns. Sensitivity analysis is there to help you say, like, in this range of, specifying an independent variable, what effect does that have on other variables I have in my process that I'm interested in. So, how do things affect my compressor outlet streams, or how does changing my inlet composition affect the product quality outside of a distillation or something? You know what I mean? So when you're doing the early exploration phase of a process, don't forget to utilize something like a sensitivity analysis that really helps you explore. It's just as valuable as, the charts functionality in ChemCAD. I like to use sensitivity analysis a lot when I don't have a lot known, and that happens to me a lot of times where I'm just playing around and trying to figure out what's going on in my process, and sensitivity analysis I think is really underutilized tool. Anyway, so that's ChemCAD in a nutshell. I'm going to go back to my PowerPoint presentation here and just really drive home the best practices and guidelines for getting started in process simulation. Verify your thermodynamics, view your phase envelopes or your TPXY charts, view how your predicted vapor liquid equilibria is being modeled with the thermodynamic models you selected. Make sure that the results of your model are as expected. If you have some experimental data, if you have some kind of background knowledge, it's really important to view that early on in a process to make sure that you're getting a realistic model. Once you're comfortable with that, then you build complexity little by little. Start small, solve as you go, troubleshoot, and then add complexity to your flow sheet. As you're going along, of course, visualize your results. To me, it's easier to see patterns and problems. For example, I was looking at the phase envelope and saying, like, if I'm operating close to a pump or a compressor section close to the dew point of a gas, like, that's going to be an area of concern. If I have a liquid that's going to cavitate the pump because I'm really approaching the bubble point of that liquid, that's something I can visualize as I go along. And so that's something really underutilized. And the final thing is the analysis tool, the sensitivity study. We can make assumptions all throughout our process and solve for an ideal case, but as we want to add complexity, we want to start manipulating the model, using something like a sensitivity study where we say, hey, vary this variable from, my specified range, my boundary conditions, and see how that affects other things in my process. So am I making good assumptions? How sensitive is my process to the assumptions that I've made, and do I need to adjust those? So don't neglect those. Don't neglect those features and functionalities in CHEMCAD. Finally, I just wanted to point out there are other resources available to you. I apologize if natural gas isn't that exciting or relevant to your work, but again, we have something like 800 different organizations around the world, and we have customers who make sugar, and who make traditional chemicals, and who make batteries or whatever. There's so many different processes. I mean, natural gas as well, LNG. So there are so many different processes that our customers use. It was really difficult to find like one model to even get started with. But next year, we're going to offer a lot of different webinars with all the different industries and starting points. So if this was too basic for you, there's going to be more complex webinars, more advanced use cases, for webinars in the future. There's also, if you visit chemstations.com, there's some more useful information there. We have some knowledge articles that you can look at. We have a YouTube channel, a ChemStations YouTube channel. If you look at the Did You Know playlist, there's a few things in there that are just like quick topics of Did You Know ChemCAD can do that, so that will help you. Like the TPXY charts, for example, is in there if you want to look more at that. And I will be adding more videos to the YouTube channel, in the coming months. And finally, support. We have an excellent support team here at ChemStations. If you're a customer, you can email us at support@chemstations.com, and we love hearing from customers. And our support team has a lot of experience in ChemCAD, so do utilize ChemStations support if you need to have more questions answered. But I'm over time now. I apologize for that. I just wanted to say a quick thank you to everyone for watching this webinar, and I hope you have a great day.